All right, hello everyone from Algorithm. Today we're solving the first question in our little DSA study prep session. So we have Leet code 997, find the town judge. Just quickly read the problem statement. In a town, there are n people who live from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then 1, the town judge trusts nobody. 2, everyone in the town trusts the town judge except the town judge. And 3, there's exactly one person that satisfies properties 1 and 2. You are given an array trust where trust I represents a trust connection between person A and B, representing that person A trusts person B. If the trust relationship does not exist in the trust array, then such trust relationship does not exist. Return and label the town judge if they exist and can be identified, otherwise return -1. So let's quickly look at this example here. As you can see, we're giving a 2D array of the trust relationships, and it kind of, you can think of this as like almost like a graph. If we see, let's say, we can think about each person inside the town is a node. So let's say person 1 here, trust person 3. So this is a directed edge because there's the trust only flows one way. This doesn't necessarily mean that person 3 trusts person 1. So there's a directed edge to node 3. And this next one shows that person 2 has a directed edge also to person 3. And with this, we could pretty much solve the problem. So what this shows is that one of these nodes, if we want to find the node that everyone in the town trusts except the person itself and also trusts nobody, all we have to do is find the node that has n-1 incoming edges, because that means an incoming edge means that someone trusts them. So if there's n-1 edges, that means that everyone in the town except the town judge trusts that person, but has 0 outgoing edges because every outgoing edge represents a trust relationship to someone else, and the town judge can trust no one. So we'll look for that, and we're going to say, well, what do we see? We see that person 3 here has 2 incoming edges, right? And 0 outgoing edges. So we see that there's n people inside the town, and we need to have n-1 trust connections to them because they can't trust themselves. So 1 minus 3, or 3 minus 1 is 2. And we see, does anybody have 2 incoming edges and 0 outgoing edges? And we see that person 3, ding, ding, ding. 2 incoming, 0 outgoing. So this is the answer. All right, so now that you understand that on like a high level, how are we actually going to solve this? And we actually have a pretty easy trick. What we're going to do is create an adjacency integer. It's not an adjacency list. We're not going to store all the connections in some type of like array or list. But what we're going to do is have a trust score. Because as you remember, person 3 had 2 incoming and 0 outgoing. The trust score will be the difference between these two. Because let's say person 3 trusted somebody and they had an outgoing edge. So this would be 1. They can no longer be the town judge. And if we just subtract these two, so 2 minus 1, that would be 1. And then we see that there's nobody that has a trust score of n-1, which is 2. So, and if that doesn't make sense, it's totally fine. I'm going to go over how we're going to solve this. So we're going to have a dictionary, and everyone in the judge from 1 to n is going to have a key inside this dictionary. So 1, 2, and lastly 3. And they're all going to start off with a trust score of 0. And what we're going to do is iterate through our trust array. And every time that someone trusts another person, their trust score goes down because that is a outgoing edge from them. And every time someone gets trusted, their trust score goes up because we want to find the person that has n-1 people trusting them. All right. So let's quickly go through this. So we see that 1 trusts person 3, so that means their score goes down. So from 0 to -1. We see here, and we see that since 1 trusts 3, that means 3 goes up because they're being trusted, so it goes to 1. We see that person 2 trusts person 3, so their score goes down because they trust somebody. But person 3 is trusted yet again, so that goes up. And we check, and we say, does anybody have a final trust score of n-1, with n being 3? So n3 minus 1 equals 2. Does anybody have a trust score of 2? ding, 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 person 3 has a trust score of 2. And if no one has a trust score of n minus 1, then we return -1. So let's quickly go into how to actually solve this. So first, what we want to start off is with our JC list, or let's call it score. And that's just going to be a default dictionary with a store an integer. So default dict, and it's going to have an int. Next, what we're going to do is create our trust relationship. So for E, V in trust, we're going to say score at, so this means that person E trusts person V. So score at E minus equals 1 because they're trusting someone, so their score will go down. But this means that person V is being trusted, so their score should increase. So score at V plus equal 1. Perfect. And now all we want to do is iterate through our score map and see, does anybody have a trust score of n minus 1? So let's say let's make a variable called judge, and we're going to call that n minus 1 because that'll be our judge score. And what we want to do is have a for loop that goes from 1 to n, right? Because we want to check every single person inside of the town. So we're going to say for I in range, and we want to start off at 1, and we're going to do 1 plus n because the right side bounds of the range is not inclusive. So if we want to include n, we have to add 1 plus n. Next, what we want to do is say if score at I is equal to judge, which is our judge score, which is n minus 1, return I. And if that does not happen, that means there is no town judge, so we want to return -1. There we go, return -1, and let's submit and see what happens. And there we go, we passed the question, and it's actually relatively efficient. I hope you enjoyed the video. If you have any questions, make sure to comment them down below. All right, peace.